Hey, it's Plumber Tom. Don't forget to check in the comments below for a link where you can find additional resources like practice tests and courses that you can take. Your support helps me to be able to create more great content. Thanks for watching. Hello and welcome to this presentation of the International Mechanical Code. My name is Thomas, and in this presentation we are going to begin our study of Chapter 12, which is Hydronic Piping. If you like to install pipe, then you will love hydronic piping. Hydronic piping basically means that we're going to use pipes to create heat in a space, or to bring the heat into the space. There are all kinds of hydronic piping systems, large and small. Hydronic piping may be installed in residential settings in the form of in-floor heat, but it's also used in large commercial projects to disperse heat throughout a building. So what we're going to study here in Chapter 12 applies to all of that. We're talking a fairly large scope of work here, but we are going to get into the details of what code requires for hydronic heating. Now it's time for you to get out your book, have it open to Chapter 12. Let's see what we can learn about hydronic piping. Let's begin in 1201, General. 1201.1 gives us the scope of this chapter and states that it will govern the construction, installation, alteration, and repair of hydronic systems. That's all-encompassing, right? It also states that this applies to hydronic systems that are a part of heating, ventilation, and air conditioning. Now, when we say hydronic, it seems in my mind like I'm talking about heating something. But the word hydronic doesn't mean heat, does it?
Indeed, a quick Google search reveals an Oxford language definition of the word hydronic. It's an adjective denoting a cooling or heating system in which heat is transported using circulating water.
It's often used in heat, but it can also be used to cool the building. So when we have large buildings with glycol systems, that is also a hydronic system. Basically, we're going to use a fluid that we're going to push around, and we're going to apply it in different ways to treat the environment of the building, to heat it or to cool it. Therefore, this chapter includes steam, hot water, chill water, steam condensate, and ground source heat pump loop systems. Once again, that's a broad range of systems that it will apply to. 1201.2 talks about the sizing of these systems, and while it doesn't give us the specifics of how to size a system, you're going to need engineering for that, it does state that it must be sized correctly for the demand of the system. And there's a lot of calculations that goes into sizing of a hydronic system. Here's what happens if you don't size it correctly. You end up with high velocities moving through those pipes that can damage the pipes, the pumps, the components.
Warning, system damage. Warning, system damage.
If a system is not sized correctly, it will not last as long. It will wear out. So sizing appropriately, making sure that all of the pipes, all the tubing, all of the components are designed to work together in the most effective way. That's critical for these systems. Another issue that we find with a system that has not been sized correctly is that they're noisy because of the turbulence inside of that system. Now, especially as we're dealing with higher temperatures in a system, that erosion of the system happens faster at higher temperatures, and if it's not sized correctly, it's going to make it worse. Okay, so I've said a lot about that, but these need to be sized. You can't just shoot from the hip on this stuff. 1201.3 talks about the standards that we would need to meet. Similar to code, there was a standard established years ago, the ASME B31, and it applied to a lot of these hydronic or piping type systems. But it was fairly complex, so they developed a simpler version of that, the ASME B31.9, for the smaller residential applications. And the code says that is an alternative to this code if you're looking for a standard for how to build these systems. In 1202, we look at materials. And we'll talk quite a bit about the different materials going into a hydronic system. But first of all, those materials would need to meet some specific standards so that we're not putting junk together in these hydronic systems. And whenever we're installing them, they need to be clean and free from foreign materials. Here's a good practice. Anytime you're going to install anything, look it over carefully. Make sure that there's not cracks or damages or anything else on the pipe, on the fittings, so that as it goes together, you don't have problems that you're going to have to correct. 1202.3 states, of course, that the materials have to meet certain ratings. For example, if I'm doing a high temperature system, that pipe had better be able to handle it. 1202.4 gives us a number of tables that we can look at for specific standards on certain pipes. But it also states that the exterior of these materials or pipes shall be protected against corrosion and degradation. We don't want the system being eaten from the outside because it's passing through concrete and it didn't get sleeved or something like that. Table 1202.4 gives us hydronic pipe standards, listing out the types of pipe and the standards that they should meet. Table 1202.5 gives us the hydronic pipe fittings standards, including different materials that could be used and the standards those fittings would have to meet. Getting into my code book here, let's see, 1203, joints and connections, yes. 1203, if you look at your book there, is all about joints and connections, and it goes on for several pages about different types of pipe and the ways that they're connected. As we get into this section, the first thing that they list out are the different ways we can connect these joints together. Then we'll go through a list of different pipe materials and talk about which of those joining methods can be used for what types of pipe. Overall, the goal here, as stated in 1203.1, is that the joints and connections would be of an approved type. We're not going to use something that's not supposed to be installed for hydronic. And, of course, they're going to need to be tight for the pressure of the hydronic system. That means watertight. They're not going to leak. 1202.3 speaks to the preparation and the cutting of pipes. This specifically states that pipe ends should be cut square, they should be reamed and chamfered, free from burrs or other obstructions. They should have full bore opening. That means we didn't reduce the size of the pipe in cutting it, and it should not be undercut. When we say it needs to be cut square, that means the pipe should be cut at a 90-degree angle. If you're cutting with a hacksaw or a sawzall, you might struggle a little to get a perfect 90-degree angle. Find another cutter. There are plenty of different pipe cutters out there. The ones you should be using should cut a straight 90-degree cut. Now in that process, if we're using a wheel cutter, it can push some of that pipe material, the pipe wall itself, into the inside diameter of the pipe. That's why we have to ream. We come in, we ream, we chamfer, we remove the burrs. Anything that was left in the pipe in the process of cutting needs to be removed so that it doesn't junk up the system or damage components. So we ream, but then we don't want to overdo it. To undercut means that we've reamed it so far that now we're thinning the inside of the pipe wall. That can cause a weakening of the pipe or a weakening of a joint connected to that pipe. In 1203.3, as we look at joint preparation and installation, they give us 5 different ways that we can connect pipes together in hydronic systems. Now, this is going to depend on the type of pipe. Some of these methods won't work for some of the types of pipe. But here they are. We can braze, we can create a mechanical joint, we can solder, we can use solvent cement, or we can weld. Those are the options for connecting hydronic pipes. Let's see what the code has to say about each of these different methods for connecting. First of all, brazed joints. This is in 1203.3.1. It says that the brazed joint needs to be cleaned. As we're assembling that, we should use an approved flux, and the joint is created using a filler metal. 1203.3.2 gives us the mechanical joints. Not a lot said on this within the code, but it does point directly at manufacturer's installation instructions. There are a variety of mechanical connections that we can make. A crimped PEX joint is an example of a mechanical joint. But we need to follow that manufacturer's instructions, make sure we put that joint together properly. And that's why they don't list a whole bunch out, because each manufacturer may have a different way to do it. If you're going to use an approved pipe, an approved fitting, and one of these methods, you better make sure you know what you're doing. 1203.3 talks about soldering. We can solder copper together. It needs to be reamed to the full diameter. Flux should be applied, and the joint, when complete, should meet the ASTM standards. 1203.3.4 gives us solvent cement joints. Now, you might think that gluing pipe together is easy, and you're right, it's not that hard. But there are some things we should keep in mind when we're doing this. Keeping the pipe and fitting clean, or cleaning them beforehand, and free from moisture. So if it's raining when we're installing, that makes it difficult. If I'm putting mechanical piping in the dirt, I need to work harder to keep it clean. Speaking of keeping it clean or getting it clean, this code states that you should use an approved primer. Now, plumbers, listen closely. When you're assembling drainage waste and vent piping, code says in International Plumbing Code, up until 4-inch pipe, you don't have to use a primer. But is it a good idea? Well, if you talk to the manufacturers of PVC glue and glue joints and primer, they'll recommend you always use primer because it makes a better joint. In mechanical piping, you don't have the option to not use primer because we want a watertight joint. Now keep in mind the difference. Drainage pipe is not for pressure. It says it right on the pipe. And while we do pressurize it for a test, we only go to 5 or 6 psi. Here, we're talking about a pressurized system. And so, primer that baby. Lots of primer. Lots of primer on that. Lots of glue. Make sure you get a good, solid joint because this is going to be under pressure. One other point on PVC. Make sure you push that fitting together while the glue is wet. Now, the one exception here is CPVC. That does not require primer, even on these installations. But that's the only one. 1203.3.5 talks about the threaded joints. Very common in hydronic systems. You can thread steel. You can also thread some plastics, but it's kind of rare, and why would you do that anyway? I don't know. If you're going to thread plastic, it has to be Schedule 80 or heavier. That means it has a thicker wall, and you'd want to use dies that are designed specifically for plastic. If you're threading plastic. Okay. But in any case, if you're assembling threaded fittings, you probably want to give it some help. Use some Teflon tape, some thread sealant or pipe dope, and you would only apply those on the male threads. Now, why is that? Why is it that you can only put pipe dope and Teflon tape on the male threads? Well, think about this. If you put it into the female threads and you're driving a pipe into that thread, what's going to happen with all of that pipe dope that's in the threads? It's being pushed into the fitting. And you get a bunch of that over a whole bunch of different fittings. If you did that on all the fittings for a whole system, you're going to have so much pipe dope in that pipe by the time you're done. It could really junk up your system. So, not on the female threads, only on the male. And if you wanted to get into good argument, talk to people about whether you put Teflon tape on first before the pipe dope, or pipe dope first and then the Teflon tape.
Hey, you're supposed to put the tape on first. No, you're supposed to put the dope on first. What? You're weird. What? You're dumb. Nuh-uh. Uh-huh.
Code doesn't say which one you should do. Sorry. I would love to end all arguments over this entire topic by saying, this is what it has in the code. But it's just not there. So here's the thing. Put it on how you like and make sure your joint doesn't leak, and then you did it right. That's it. Yeah, it's pretty simple.
Nuh-uh. Uh-huh. Nuh-uh. Uh-huh.
All right, then we have 1203.3.6 weld joints. And yeah, there could be whole lessons taught on how you're supposed to weld pipe. I have great respect for people who can weld pipe. I'm not a welder myself, but from what I understand, of all the welding techniques that are required, piping is one of the most difficult to learn. So, hey, if you're a welder, awesome. You have a lot of value in this world, and we appreciate you. If you're going to weld, it says the joint has to be cleaned by an approved method before you weld that up. And then, of course, it has to be welded with an approved filler metal. Make sure you know what you're doing and it's welded properly. Now, there are other options in mechanical. 1203.3.7 gives the grooved or shoulder mechanical joints. And this kind of falls back into the category of mechanical joints, right? It says it right in there. But we're talking about a specific type. This is the groove or groove lock. Victaulic is one of the earlier companies that developed this and marketed this. But as a side note, Victaulic is just a brand name. It's not like the method itself. We'll call this the grooved and shoulder mechanical joint. These joints have to meet the ASTM standards, and of course you'd want to follow the manufacturer standards on how this is to be installed and assembled. There is another type of mechanical joint that can be used before soldering. This is a mechanically formed T-fitting. Another description for this is an extracted T, where you're not actually cutting into the pipe and installing a T, you're creating a T from the wall of the pipe itself. This, if you ask me, is almost outdated. Not many people are using this method because there are other methods, like press connect. But here's what is required if you're going to extract a T and then if you're going to braze that up. It has to have a height of not less than 3 times the thickness of the branch tube wall. These walls are not that thick, but we need to get that T raised up high enough that we have some real connection between the pipes. The branch tubes should not restrict the flow of the run tube. That means if I'm inserting a tube down into that T that's been pulled, I don't want to push that pipe in so far that it starts blocking the flow of the pipe it's connecting to. A dimple and depth stop should be formed on the branch tube, so that's going to keep it from doing that, from pushing down in too far. And the second dimple should be a 1/4 inch above the first. This helps me to see if I've pushed it in or if it's gone in far enough for me to create a good joint. Then the dimples must align before this is brazed. This is going to be a brazed joint. This does not give enough of a connection for a solder joint. And like I say, I don't know that many people are doing this anymore, but it is in the code as an approved method. Now that we've looked at some of the methods for joining pipes together, let's go through the different pipes that can be used in a mechanical system and see which of those methods apply to which types of pipe. We'll start in 1203.4 with ABS plastic pipe. Plastic pipe should be solvent cemented together. That's the only option they give us for ABS plastic pipe. Please notice that in a hydronic system, you're not going to be using the same ABS as you would for DWV. We're talking about solid wall, Schedule 40. This stuff's hard to find. In fact, I had a hard time even finding pictures of it, and that's why you get a DWV fitting on the screen right now. But don't use that on hydronic, please. Let's go on to 1203.5, which is copper or copper alloy pipe. This is different than the normal pipe that we'd install that's copper, the copper tubing. It's easy to get. Here's what you can do with this. You can braze it, you can use mechanical joints, you can solder it, you can use threaded joints, and you can weld it. Yes, threaded copper, rare as that may seem, you can imagine it's going to have a thicker wall than your normal copper tubing. Which brings us to 1203.6, which is copper or copper alloy tubing, far more common than the last thing we looked at. It can be brazed. You can use mechanical joints, you can use soldered joints, you can use flare joints, you can use push fit and press connect, if you're following the manufacturer's installation instructions, of course. Copper is a very common pipe used in hydronic systems. 1203.7, CPVC plastic. You can use mechanical joints, solvent cement, or threaded joints to join this stuff together. How about another variety, 1203.8, CPVC, CPVC. This has an aluminum layer between two layers of CPVC plastic pipe. You can use a mechanical joint, a solvent cement joint, or threaded joints to put this stuff together. Check out 1203.9 polybutylene plastic pipe and tubing. You can use a mechanical joint or heat fusion. There's a variety of options for heat fusion. When you're fusing pipe together, you're going to heat the pipe, you're going to heat the fitting, and you're going to push them together. Notice we have an example of butt fusion on the left. Two pipes are pushed against a hot plate. The hot plate is removed and the pipes are pushed together end to end. That is butt fusion. Then we also have the socket type. The pipe and the fitting are pushed into a heating tool. The tool is removed and the pipe is pushed into the fitting. In any case, when you're doing fusion to put pipes together, you have to make sure they are clean and free from moisture, and you need to leave them undisturbed until that plastic has fully cooled. On to 1202.10, cross-linked polyethylene, our favorite PEX tubing. These can be conjoined with mechanical joints, compression type fittings, using inserts or ferrules or O-rings, of course. You know, the stuff we use to put PEX together. Now, if you're going to use PEX and you're going to transition from plastic to metal, you're going to need an adapter. If you put an adapter on there, here's a basic pattern for soldering an adapter. Solder the adapter, let it cool, then crimp your PEX. You need to make sure that you're soldering at least 18 inches away from the plastic tubing if the tubing is connected to the metal and you're soldering the metal. You understand what I'm saying? Keep it cool enough that you don't overheat the PEX. There is also an option on PEX for push-fit fittings, but you'd want to follow the manufacturer's installation instructions. Moving on, we have 1203.11, which is simple PVC plastic pipe. You know it, I know it. It can be solvent, cemented, or threaded. That's about all you can do, but make sure you're not using DWV. Next, we have 1203.12 steel pipe. This is very commonly used in hydronic systems. Steel pipe can be connected using mechanical joints, threaded joints, and welded joints. But don't forget 1203.13 steel tubing. This can only be connected mechanically or welded. 1203.14 is polypropylene plastic. That's a lot of P's, man. Aquatherm is a common name among manufacturers for polypropylene plastic, and it is put together using heat fusion. You can use a socket type for polypropylene. You can use electric fusion type for polypropylene, or you can also use butt fusion. And these joints likewise would need to be clean and free from moisture and left undisturbed until they have fully cooled to have a solid joint. Mechanical and compression sleeve joints are also an option. Follow the manufacturer's instructions. 1203.15 gives us the option for raised temperature polyethylene plastic tubing, or PERT. These can be combined with mechanical joints. Similar to PEX, we have compression type fittings. We'd want to use inserts, ferrules, or O-rings as required. Also, if you're using PERT, if you're connecting plastic to metal in this hydronic system, and if you need to solder, and if there's plastic anywhere nearby where you need to solder, make sure you're soldering at least 18 inches away from the plastic tubing so as to not overheat it and weaken the wall of the plastic pipe. Remember, solder, cool, then crimp. Push fittings are also allowed. For PERT piping, follow the manufacturer's instructions. 1203.16, polyethylene, aluminum, polyethylene, or PEALPE pressure pipe. Similar to PEX, these are combined with compression type fittings. Use the inserts, ferrules, or O-rings as required. And just like I already said, on soldering, keep it away from the plastic. Solder, cool, then crimp. 1203.17, cross-linked polyethylene, aluminum polyethylene, or PEX-Al-PEX. This gives us PEX on the inside, PEX on the outside, with a welded aluminum layer in between those two layers of PEX. These can be combined with mechanical joints just like the other PEX, as we've already talked about. Keep your soldering away from the plastic, solder, cool, and crimp. But let me also point out with these that have aluminum inside the PEX walls, they're able to hold their own shape. So you could bend a 90 and it will hold that shape. This is kind of the nice thing about this type. That goes for any of these that have aluminum in between the plastic walls. And there you have it. There are a lot of options for us when we're running hydronic piping for different materials that we can use and ways that we can put those together. The key here is to make sure that we're using the approved methods so that we don't have problems later. And that does it for this presentation of Chapter 12 from the International Mechanical Code. We're looking at hydronic piping and we've covered from 1201 to 1203. Join me in the next presentation. We'll pick it up in 1204 as we talk about pipe installation. I will see you there.
Okay, I think that does it. This must be the end of the video.
Nuh-uh. Uh-huh. Nuh-uh. Uh-huh.